When we start talking spindles and the critical features of spindles, we have to talk drawbars. It's holding your tool, it's creating rigidity between your tool and your spindle. So when we talk about the componentry of a drawbar, obviously you have a draw rod, the shaft that creates all the tension with the springs inside of your spindle. There are many things we have to look at when we're evaluating drawbar designs or even repairing spindles and repairing drawbars. But we replace obviously springs every time. We put new seals inside of the drawbar as well. You have to evaluate your gripper fingers. You know, there's a lot of wear and there's a lot of evidence of wear you can see inside of your gripper fingers. And when that's damaged, you do not want to put an old set of fingers back inside of a spindle. Obviously, you have your condition of your signal ring and your proc switches that are picking up your signal ring, which becomes a safety issue if those aren't all functioning properly. You've got your 3 positions: clamped with tool, clamped without tool, and unclamped positions. So we have to be able to sense all of those positions properly. And then of course, how you set up your springs has to be original to the OEM. You have to make sure you're using the original spring design to get the same pull force and functionality out of your drawbar. But when done right, you have the proper pull force and it gives you the right spindle specs to be successful when you're machining. Another critical component to the drawbar is when you have coolant through the spindle by use of a coolant union. And along with our drawbar, we have to ensure that the drawbar has the same runouts as your spindle. The face, the pilot, and the threads all have to be running together. They have to be to specification, the specifications of the coolant union. So we'll ensure the size of everything is to spec and make sure that back face is to spec to ensure that that coolant union runs for a long time.